Hello students, I'm Miss Berguitta from Perseverance Secondary. Welcome to our chemistry class. The topic today is experimental techniques with the subtopic purity. The objectives covered will be demonstrate an understanding of paper chromatography, interpret simple chromatograms including RF values, and assess purity based on melting and boiling point. So first of all, we will look at paper chromatography. This is something which most of us are familiar because we've done it before. So this technique is used to separate substances that have different solubilities in a given solvent. Example, different colored inks that have been mixed together to make black ink. Note, if a substance is water soluble, then the solvent to be used will be water. However, there are a lot of substances that are insoluble in water. Therefore, you cannot use the solvent as water. You'll have to find another solvent. Other solvents that you can use is alcohol, ethanol, or even an ester. It can be used instead of water. Let us see how we set up the chromatography paper. So we're going to use a black ink. We're going to test the black ink, and then we have different reference inks. We've got red inks, blue ink, and yellow ink. So we'll draw the line, we'll draw the baseline in pencil. Please note that the baseline needs to be drawn in pencil, because otherwise, if it was drawn in ink, it will run into the chromatogram along with other samples. So it needs to be drawn in ink. So you put your ink, your black ink, and your reference materials on the baseline. Now, the second part is you have to lower the paper into a beaker with the appropriate solvent. As I said before, there are appropriate solvents. Not all solvents will be appropriate. If the substance is insoluble in water, though water is a solvent, you cannot use water as the solvent because the substance is insoluble in water. So you will use an appropriate solvent based on the solubility of the substance to be tested. Now make sure that the pencil line is above the level of the solvent, because if it's below, the samples will wash into the solvent container and you won't get a chromatogram. After you set it up, you will wait for some time and allow the solvent to travel up the paper. Then as it has finished traveling up the paper, then we can analyze the chromatogram. We'll see that the black ink will have separated into different substances, and you can use the reference material to see if really the black ink contained all these reference materials or which reference material was present in that black ink. Now in this case, the one that is shown now, you will see that the black ink contained the red pigment, the yellow pigment, and the blue pigment. But note that not always will all the reference material or reference substances be present in the ink or in the substance that we are being tested. Please note that different substances have different solubilities, meaning some are very soluble in the solvent and some are less soluble in the solvent. If it is very soluble in the solvent, then the substance will travel faster. So you will have it at the top, the very top of the chromatogram. But if it is not that soluble, it is less soluble in the solvent, then it will not travel further and it will travel a shorter distance. So interpreting the simple chromatograms. If two or more substances are the same, they will produce identical chromatograms. So they will be there at the same level. If you take two spots of ink from the same pen, then their chromatograms will be identical because these substances are the same. If a substance is a mixture, it will separate on the paper to show the different components as separate dots. When you get separate dots, then that means there are separate components. Based on the number of dots that you get, then you know how many components there are in the mixture. An impure substance will show up with more than one spot. And a pure substance will only show a single spot. So impure substance will have more than one spot, meaning 2, 3, or 4. And a pure substance will have only one spot. Now, in real life, we don't always use colored substances when we are using chromatography. So what happens, sometimes you use chromatography to separate the different mixtures, but these substances in the mixture are not colored substances. So they are invisible to the naked eye. Such are proteins. So what happens now? Chemists have to use another step. They have to employ another step for them to be able to identify or for them to be able to interpret the chromatogram. So what they do, they will spray or they will apply substances on the chromatogram which will make the spots, the invisible spots, visible now. Will react with the spots and they will become visible to the naked eye. These substances that you add to the chromatogram to make invisible spots visible are known as the locating agents. There are other things you can do to interpret the chromatogram, and another one we do is calculating the retention factor. The retention factor values is specific for one particular compound. So it is the same value for a particular compound. And these retention values, if chemists have calculated retention factor values for a lot of substances, and you've got data tables as shown, you've got some data tables of specific RF values for different compounds. These RF values can be used to identify a compound. Let us say you take a sample and you analyze it using chromatography, but you do not know what is in the sample. What you can do, using your chromatogram, you calculate the RF value of that sample on your chromatogram, and then you will compare the value that you have. You compare it to the value, the data tables that scientists have already calculated. You compare it to the data tables so that you can identify which substance it is. Okay? And the RF values are usually unique for different substances. So how do we calculate the retention factor value? So we take a chromatogram whereby we identify different components. The first one we need to identify is the solvent front. The solvent front is the furthest distance traveled by the solvent as shown here. So this is the solvent front. Then you need to identify the baseline. The baseline is the line drawn in pencil that we drew before we did the experiment, where we placed the spots, the inks to be analyzed, the samples to be analyzed. So RF value is calculated by distance moved by the compound. So distance moved by the compound is measured from the baseline to the spot. Okay, so it is measured from the baseline to the spot, to the sample, to the compound. Divided, RF value divided by the distance moved by the solvent. The solvent, distance moved by the solvent is measured from the baseline to the solvent front. So you take these two distances and you divide it together, distance traveled by the substance divided by distance moved by the solvent, you get the retention factor. Please note that the RF value is a ratio and therefore has no units, because you're taking distance, you're dividing by distance, so there will be no units. Assessing purity. So pure substances, how will we know a substance is pure? One way to know is that pure substances melt and boil at specific and sharp temperatures. Example, pure water will melt at 0 degrees Celsius and it will boil at 100 degrees Celsius. So it's a specific temperature, and the temperature, the melting and boiling point is sharp. It's not a range of temperature. It's not 101 to 103, but it is 100. It's a sharp temperature. And melting point data and boiling point data tables can be used to distinguish pure substances from mixtures. Let's say we've got we take a sample of water. We want to identify whether this water is pure or not. So we boil it. When we boil it, we check its boiling point. If it boils at a temperature higher than 100 degrees Celsius, then we know that this sample of water is impure. It is a mixture. The moment something is impure, that means it is a mixture. There are other substances added to it. Now, mixtures, remind yourselves that mixtures will melt over a range of temperatures as they contain more than one substances. Okay? So the first question, let's look at the first question. So it says paper chromatography was used to determine if a band preservative X is present in 4 samples obtained from 4 different packaged foods labeled A, B, C, and D. The results of the analysis of the foodstuffs are shown in the diagram below. So you've got X. X contains 2 substances in it. It contains 2 substances. So let's look at A. A, it contains only this substance. So therefore, it does not contain both of the substances from X. B, it contains this substance, which is the same present in X, and it contains also this substance, which is also present in X. C, it does not contain this one, but it does contain the top one. Whereas D, it contains this one, the lower one, but it does not contain the top one. So the only sample, food sample, that contained both this one, the top one, and this, the lower one and the top one is sample B. Okay, so the answer is B. This is the only one that contains the sample X. Now let's look at the other question. Esters can be used as solvents in chromatography. The following shows a chromatogram of plant acids. So you've got the solvent front, you've got the baseline. Then you've got 2 samples. An ester was used as a solvent and the chromatogram was sprayed with bromothymol blue. Okay? So suggest why it was necessary to spray the chromatogram. For this one, it's just to make the invisible runs, the invisible spots, visible. Bromothymol blue is a locating agent, so it just makes the invisible spots on the chromatogram visible to the naked eye. Now, the second part is explain what is meant by the RF value of a sample. What is the RF value of a sample? We've covered this, and to make life easier, we can just give it as a simple definition. It is the distance traveled by the sample divided by the distance traveled by the solvent. Please note that RF value will always be decimal and it will be always smaller than 0, because always the solvent will have traveled a longer distance than the sample. So we're dividing a small number by a bigger number, so you get a decimal and you get a number less than 0, always. So to conclude, what did we see? So that chromatography can be used to separate mixtures that have different solubilities in a solvent. RF values, the retention factor values, are calculated by dividing the distance traveled by the substance divided by the distance traveled by the solvent. And pure substances melt and boil at specific temperature known as the boiling and the melting point. So we have come to an end of the lesson. Thank you for listening. Hope you have understood the lesson and the concepts taught. Stay home, stay safe. Goodbye.